So we've got our graph over here. We're going to be doing transformations to our absolute value function. We're going to start by adding or subtracting outside of the function first. And it would probably make sense that it's going to follow our general rules where if I add on the outside, it's going to move my function up or down. So let's start by just graphing the absolute value function. It's going to look like that v, but let's just kind of throw it into our calculator just in case. So we've got it here. I guess I'll do that in blue since it's starting in blue. So I'm going to get to math, go to num, abs, and just the absolute value of x is my basic absolute value function. And when I graph it, it should look something like that. If I want to get the actual values for that absolute value function, I'll hit second and go to table. And that's going to bring me over to these x and y values that I'm going to use. So I'm going to plot the points, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, going on like that. But then also I need the negative side of my absolute value function. And it's going to be up over here where every time you put in a negative x value, you end up with a positive y value. It's just the distance from 0. So I'm going to start plotting those points. Negative 1, 1, negative 2, 2, negative 3, 3, etc. And our function does look like that v that we saw graphed in the graphing calculator. So next what we want to do is try doing some transformations by adding different values. This first one I've got here, I'm going to add 2 to it. And we think, based on our rules from the other day, we think that that means that this should move this whole graph up by 2. And let's just check it on the calculator to make sure. But once you know these rules and you know what the absolute value graph looks like, you don't need to go to the calculator. Graph your absolute value graph, and then you can just move it around based on those transformations. So I'm going to go to num, absolute value, x, and I'm adding on the outside over here, right? I'm outside of the function, so I have to make sure that I'm not inside like I've got there, but that I'm outside. I add that 2, and this graph, let's just make sure, in red it's showing, it looks like every single point moved up by 2. And so we'll do that over here. If you want, you can check your table. It should give you now, this is your x's and your new y's are in red over here. But I think you can also just do it by eye where I look at each point and I'm going to say, all right, it's plus 2 on the outside, it goes up 2. Plus 2 on the outside, up 2, up 2, up 2. And eventually you should have enough points where you can just take a straight edge to it and graph out that new absolute value function after it's been moved. After it's been transformed by adding on the outside. Now we also said, as I'm finishing up this graph, we also said that if I subtract on the outside, it makes it goes down. But what I've got over here is I actually don't have any subtractions here. So adding a negative is really just the same thing. Let's double check again to make sure that if I add a negative, that my original graph, it should go down. So I can go to my y equals, do math, absolute value of x, minus 3. Let's check that graph to see if it's going down where it belongs, and it looks like I shifted everything down by 3. So I'm going to do just that. I'm not even going to check my table. So I'm going to take my original point, shift down 1, 2, 3. Shift down 1, 2, 3. 1, 2, 3. And you can kind of, once you see where you're putting your vertex, the center point of your absolute value, you can kind of know where to go from there instead of checking each one. So I'm going to graph those points and just draw out the lines. What I recommend you do is, I'm not going to go through all 4 of these different ones, but I recommend just trying a couple transformations yourself and seeing what it looks like. Let me make sure I've got this lined up well. There we go, that's looking better. Just like that. So that's my shifting up and down by adding on the outside. And so the k is what values I'm adding over here, and it moves your graph up and down. Moves the graph, or function really, up or down. All right, let's turn on to that next page over here. In this next page, we've now got the shifting going on the inside of my function. You see how I've got the line up here, the absolute value line, and then now I'm subtracting or adding inside. That's going to do a different type of shift. So I'll clear out these guys from the outside, keeping my original function. And now I'm going to do math absolute value, but let's do minus 4 on the inside. That should be okay. So I'll do minus 4 on the inside. So I'm going to do x minus 4. And if it's right, I think our inside rule should stay the same. It's going to push it to the right a little bit. And if you take a look right over here, I've got my original graph, and I go 1, 2, 3, 4 to the right. So I'm just going to take a moment and draw out my graph and graph the original absolute value, and then we'll graph it after shifting 4 to the right by subtracting 4 on the inside. So let me just draw my y over here, draw my x over here, my x-axis, and let's draw our original absolute value function, which you're centering it at 0. You go up with a positive 1 slope, 1, 1, 2, 2, 3, 3. It's making that V. I kind of made my slope a little messed up, but that's good enough. And then in the negatives, you're always returning positive values, so that's why I go up in the y over here. That's my original function. Now we said we shifted 4 to the right by subtracting 4 on the inside. That follows our regular transformation rules. So let's just make sure we take this and we shift everything 4 to the right. So I'm going to go 1, 2, 3, 4 to the right over there. And if you want, you can take each point and go 1, 2, 3, 4 to the right from here. 1, 2, 3, 4 to the right. Or you can say, hey, here's my vertex, and I know absolute value. I just go up 1 over 1, up 1 over 1 to the right, and I'll get a line that looks like this. And going to the left, I go up 1, and then instead of just to the right 1, I'm going to go to the left 1. It's that kind of opposite slope. Alrighty. So this is shifting it to the right when I subtract it inside of my function. And similarly, I can also subtract a negative, or I could just add inside my function. So let's say I do minus -2. Well, that's going to be the same thing as absolute value of x plus 2. And I know that my transformation, if I go adding inside, it should be shifting it to the left. So let's check there. Y equals absolute value. So I got to go to math, x plus 2. And we're going to take a look at that graph. And it looks like I shifted it 2 to the left, just like we expected. 1, 2 to the left. So I'll draw that one really quick. And then we'll look at our final type of transformation here. That's going to be my absolute value shifted 2 to the left. And then this one over here. So by the way, when I'm adding or subtracting on the inside, it moves your graph, moves left or right. Okay. Now, finally, we're coming to this last one. It starts to look a little bit weirder. We are going to choose some values where I'm going to multiply outside of the function. So let's try multiplying outside of the function. And I'm going to try 2 different ones. I'm going to try times 2, just a regular whole number. And I'm also going to try by a fraction, because I know based on our previous transformation experience that numbers that are whole numbers, they're going to do one thing, and numbers that are fractions less than 1, they're going to do another thing. So let's try maybe 1/2 after that. and let's see what that graph looks like. So again, let's make our XY on here. And that way for the X-axis. Alrighty. And I'm going to come back to my graph. I'm going to clear out, moving to the left and right. And let's try, we're multiplying on the outside this time around. Let's try that out. 2 times the absolute value of x. And what happens there? This blue one is my original, just so we have a reference point. And this red one coming in is my new one. It looks like it got kind of squished in. If you remember when I multiplied by a whole number before, it kind of pulled things up. And if you think like it, you're kind of pulling these lines up, and it kind of becomes a little bit tighter of a V over there. So let me draw my original absolute value function centered at 0, 0, and then just going up 1, 1, 2, 2, 3, 3. And then when I get to the negatives, you still are returning positives, so my y's all still have to be positive here. That's the whole idea of an absolute value function. But now I've got this new one. I'll do that in black pen. It looks like it's going to be kind of tighter inside. It's hard to see exactly what happens. Let's check the table to see exactly where I belong on these points. So that's going to be my red one. Well, 0, 0 is still the same. Then I'm going to have 1, 2 as my next point. So positive 1, positive 2. And let's see what happens there. It's going to be positive 2, positive 4. Positive 2, positive 4. It looks like my slope over here was up 1 over 1, up 1 over 1. When I multiplied by 2, it made my slope go up 2 over 1, up 2 over 1. It doubled my slope there. Let's double check it on the negatives. Negative 1 goes to positive 2. Negative 2 goes to positive 4. So it's doing exactly that. It made this slope steeper when I multiplied by a whole number, and it made it by exactly the amount that I multiplied by. No tricks or anything, no surprise there. And let's try one final transformation, multiplying by a fraction. Well, if I multiplied by a whole number, it kind of came in, pulled these lines up. Maybe multiplying by a fraction, it's going to squish it down, push these lines down this way. Let's see. We'll come back to the calculator, and I'm going to try out, all right, what about 1/2 times the absolute value of x? Let's check that graph out. And it looks like it's doing exactly like we thought it was. You're going squish down a little bit more for it. Your steepness of your slope is getting less steep. Let's graph that last one. I think I got to go to the table to get the exact values there, and let's see what happens to the slope. So now here I was at 0, 0. Then it becomes 1.5, or I can even do 2, 1 is the next whole number. So I can go 0, 0, 2, 1. And I bet it's going to be 4, 2 is my next one, right? I've got 4, 2 is my next one. It did exactly that. It took your slope and it cut it in half. Same thing with the negatives. Negative 2, positive 1. Negative 2, positive 1. And then negative 4, positive 2. It made it kind of squish down a little bit of a wider angle when I've got multiplied by a fraction for my absolute value. I recommend trying out some different values, multiplying them, throwing them into your graph, and maybe even generating the tables yourself so you can kind of really see what's going on there. But that's pretty much it for transforming my absolute value functions. When I multiply, it's either going to make it kind of a tighter angle or a wider angle. When I add on the inside, I'm shifting left or right, going opposite from the sign that I saw. And when I add on the outside or subtract on the outside, I'm going up or down. And these can, of course, all be combined together to make some scarier thing where you're going up, then left, and then you're shifting it inwards. But the ultimate thing is those same transformations that we saw with just our regular piecewise functions.